Hello guys, and welcome back to the CCNA video series brought to you by ABY Design and Tech. In this video, we're going to focus on the base configuration, the minimum configuration you need to get your Cisco router working when it's fresh out the box. Now guys, remember, every video that you watch in this series is one step closer towards achieving that goal of passing the CCNA exam first time. So let's focus so that we can learn as much as possible. So far, during this series, we have focused on layer 2. More specifically, we focused on layer 2 technologies that we can use to improve and build a layer 2 network. A layer 2 network just allows devices which are in the same subnet, in the same network, allows them to communicate. So, technologies such as VLANs on a switch allow us to segment our broadcast domain into multiple separate broadcast domains so that we can improve the congestion on our links, and also so that we can add some security to our network. Span entry protocol, focusing on optimizing the layer 2 forwarding paths. Power over Ethernet, focusing on getting power to those devices where maybe they may be located in areas where it's hard to install an actual power unit in those places. So the point is, we've been focusing strictly on layer 2. Now it's time to think bigger, to move towards layer 3, because you're probably thinking, well, Abda, I know how to set up the network for my office, I know how to set up the network for the campus or for whatever enterprise I work at, but there has to be more to it, in that even though I've set up this network so that devices can all speak to each other, we want to get devices in different networks, in different subnets. We want to get those devices speaking to each other, and we need to use a layer 3 device in order to facilitate that communication. So layer 3, this is where we can get devices in separate networks. We can get them talking to each other by using layer 3 devices. A prime example is a router or a switch. And to be fair, a prime example of what we've covered so far are VLANs, because obviously we implement VLANs so that we can make our broadcast domain smaller, so that we can have some security in that we can't speak to anybody without having to go through a layer 3 device where we can implement some security policies. However, we don't want to completely cut off all communication between VLANs. We want the majority of our devices to be able to communicate if they're in different VLANs, but obviously we are forcing them through a layer 3 device in the first place so that we can have some control over who can speak to who. And this is where the router comes into play. So a router, its primary job is just to allow you to get off your network and talk to somebody who's on another network. That's all it does. And routers, they're used to build wide area networks. So a wide area network is a large network which spans many miles. And all a wide area network does, it connects multiple LANs together. A prime example of a wide area network is going to be the internet. The internet allows people across the globe to be able to communicate. It allows people across the globe to be able to keep in contact with each other and communicate. And that is one of the most obvious, one of the biggest examples of a wide area network. The routers, they just allow us to get off our network and speak to somebody else who resides on a different network or on a different subnet. So in this video, we're just going to cover the base configuration of a router, and this is very important because unlike a switch, a router with no configuration will not work at all. A switch, if we were to get a switch out the box, power it on, plug some devices in, as long as the devices are on the same network, they will be able to communicate with each other. A router, let's say that you want to facilitate some inter-VLAN communication. You want devices in different VLANs to be able to communicate, or you want to connect your router so that you can access the internet. Well, by default, without any configuration, your router will not work out the box. Now, I know what you're thinking. You're thinking, well, wait a minute, Abda. How come when the BT man or the Virgin Media man comes around my house and installs my new home router, how come that works out the box? Well, the reason being is because those devices, they already have some sort of configuration before they're installed at your house. They have the minimum configuration needed in order for them to work, in order for them to do their job and allow you to access the internet. However, Cisco routers, they've got no configuration on them by default, so we have to put some configuration on them in order for the router to do its job and route between networks. And so one of the reasons why this is the case is because unlike a switch, a router, its interfaces are layer 3, meaning they represent a single broadcast domain. So each interface is in its own broadcast domain, meaning if a router does receive broadcast packets, they don't go any further than him. He acts as the broadcast barrier. Now, with that in mind, it means that we then have to go and configure IP addresses on those interfaces because they're layer 3. So unlike a switch where all of its interfaces are layer 2, a router, its interfaces are layer 3. So we have to have some basic configuration on them in order to put them into a network. And so just to make things interesting, as well as doing the basic configuration, we're going to assume that we're the network engineer for this small environment. Just imagine this as a small office with a few employees. So we've separated our office into VLAN 10 and 20. VLAN 10 is going to be the green VLAN, VLAN 20 is going to be the red VLAN. And we want to install a router with some configuration on it, with the minimum configuration needed to get these two devices talking. And that's what we're going to do. So on the router, FA0/0 is going to be connected to the VLAN 10, so to the green VLAN, sorry. FA0/1 will be connected to the red VLAN, so that's VLAN 20. So I'm going to pause the video. The next time you see my screen, I will be at the command line interface of a Cisco router. Hi guys, so welcome back to the CLI of the router. And like with a switch, the first question you're going to be asked is, do you want to enter the initial configuration dialog? You'll be asked this with every new switch or router with no configuration out of the box, and as always the answer is no, because we're professionals. We're going to put this configuration on this device ourselves. So just like with a switch, we're in user mode. We have to move into privilege mode and then into global configuration mode in order to configure the device. The first item, or the first configuration item on our list, is going to be the host name. I will change it to R1, and to be fair, the configuration apart from the interface configuration for the router is going to be exactly the same as the base configuration that we saw on the switch. So I'm just going to blaze through this. So once we've configured the host name, we now need to configure our enabled password. So this could be a secret or enabled password. This means that when I move from user mode to privilege mode, I will be prompted for a password, because once you're in privilege mode, you can get into global configuration mode and start changing all sorts of stuff on the device. Once we've done that, let me configure a username and password, which will be stored in our local database. So the local database is a database on the switch stored locally, and it's got the username and passwords of each account that we've created. And so when a user wants to connect to the device for management purposes, we can prompt the user for a username and password, and then we can compare what they've entered to the entries in the local database. So we go into line console 0. Let's configure that login local, which means, again, when someone wants to connect to your console line for management purposes, just prompt them for a username and password and then compare what they've given you to the local database on the router. Logging synchronous, telling the router that please do not interrupt me with system messages when I'm on the device configuring you, because that is really, really annoying. Exec timeout, telling the device that don't time out, please, because you're a lab device and it is a real pain in the backside. We exit from here, line VTY04, configuring the device for remote management. Login local. Again, if somebody wants to connect to you via SSH or Telnet, just prompt them for a username and password and then just compare what they've given you to the entries in the local database. Last item we're going to configure before we go over to the interface configuration is going to be the login banner. So banner login. Again, show the user some sort of message when they connect to you for management purposes. Normally this would be something like this: unauthorized access not allowed, or something. So your company will give you a message and it'll essentially just be a disclaimer saying that unauthorized access is not allowed. If you're caught, you will be prosecuted, etc, etc. So I'm just going to put unauthorized access not allowed in capitals. We end with the delimiting character. And before I go any further, before I start doing the interface configuration, so to be fair, that's all the configuration done, all the basic configuration done on the router itself from what we've seen or what we've already configured on the switch. Before we go any further, I'm going to confirm that my laptop that I'm recording on, who's in VLAN 10, that I cannot ping the device in VLAN 20. So let's try to ping that, and obviously, as I expected, no response. So now I'm going to go back into privilege mode, do a show IP interface brief command, and as you can see, we have 4 interfaces on the router. We're plugged into FA0/0 and FA0/1. One of the main differences between the switch and the router is that with the router, the interfaces by default are administratively shut down. That means that the shutdown command, so if I do a show run interface FA0/0, the shutdown command is enabled on the interface by default. So obviously we have to issue no shutdown to bring the interface up. Configuration terminal, let's configure those interfaces. So interface FA0/0, that's connected to VLAN 10. So I'm going to configure that with the IP address 192.168.10.1, subnet mask of 255.255.255.0. Again, the subnet mask identifies, okay, the first 3 octets of my IP address represent the group that I'm a part of, represent my network. So any devices in my network have to have the same first 3 octets. The last octet of the IP address, that represents who I am within this group. No shutdown again. No shutdown. If I go over to interface FA0/1, and now we're going to configure the interface for VLAN 20. Again, the way that we do this, we literally just enter an IP address in VLAN 20. So on the switch itself, the 2 interfaces which connect to the router, I've already configured those interfaces on the switch in VLAN 10 and VLAN 20 respectively. 20.1, 255.255.255.0, no shutdown. Brilliant, so those interfaces should both be coming up. Now, before I do anything, let's do a few ping tests to make sure that my router can actually, in fact, reach my hosts. So 192.168.20.1. Oh, sorry, that's myself, isn't it? 20.10. Now, you may see that with the pings, it may take a moment or 2 for the pings to actually get through. The reason being is because the router has to start building the op cache. The question is, did I bring the interface up? Show IP interface brief. Okay, so I did bring the interface up. Why isn't that working? Can I ping my laptop? 192.168.10.10. Okay, so I can't ping those devices. That is a bit strange. That is... Okay, so that's not what I expected. I'm just going to jump over to the switch, obviously behind the scenes, so to speak, just to check what configuration there is there. So welcome back, guys. The mistake was mine. So what I'd accidentally done, I'd run a cable from FA0/1 into FA0/8 and vice versa. So I actually got the interfaces that I was plugging into mixed up. So now, if we issue that same command, 192.168.10.20.10, that should now work. So just give it a second to, yeah. So as you can see, we dropped the first ping. The reason being is because we have to build that op cache on the router. And then we issued the same command again, because remember that with the router, it's going to be processing packets, IP packets. So it's going to be looking at the layer 3 header. So then when it then has to forward on a packet, it needs to know the layer 2 information to add on to the data so that it can forward it to the correct device. So let's now ping 10.10, make sure that, okay. So as you can see, my router can now ping the host in either VLAN. If I go back to command prompt and I issue a ping of my own. So let's ping my default router at first, 10.1. Okay, as I expected, it works, fantastic. And then moment of truth, can I ping that device in the other subnet? And yes, I can. So just like that, it's magic. I can ping my device, and we only needed a few lines of code or a few commands on the router to actually get this up and working. So now I can have devices in VLAN 10 and VLAN 20 being able to communicate between each other. Obviously, we're one step closer towards achieving the goal of having a router facilitate communication between anybody. So between any network, we're one step closer towards our goal. At the moment, we've just got inter-VLAN communication, which is fantastic. So another thing I wanted to show you is the routing table on the router. So when a router decides that it wants to forward on a packet, how does it know where to forward the packet onto next and who to forward it to next? And the answer is, just like a switch has got the MAC address table holding all the MAC addresses and how to reach them, a router has got what is known as a routing table. So this routing table is pretty self-explanatory. It just holds each network that this router knows about and how to reach that network. So as you can see, the router knows that, okay, I can reach the VLAN 10 subnet, so I can reach 192.168.10.0/24 by using fast Ethernet 0/0, and I'm directly connected, so I have a physical connection into this subnet. The same as with VLAN 20, I can reach 192.168.20.0/24 directly connected via fast Ethernet 0/1. So this is a code here. So over here on the left, you've got the codes for the routes. If we see a C next to a route, that means that the router has got a direct connection. It's directly connected to that subnet. L is just a local route. So this is a route to a router's local interface IP address. So he knows that, okay, if I have a packet and it's destined for my IP address, then I know to route it there straight away. And the reason why the router has this is because we'll dive into this a bit later, but when it comes to routing traffic, the route a router chooses is based on the most specific route. So what the router doesn't want to do, imagine that the router didn't have this local route, it just had these connected routes. Let's say that somebody wanted to communicate with the local interface on the router. The router may actually in fact forward that traffic out of one of its interfaces, even though that traffic is actually destined for its local interface, because there isn't any route in place. So by having this route in place, it ensures that any traffic destined for the local router's interface matches a route, and then the router can then process that traffic. And guys, that's all there is to it. So that's the base configuration for a router covered. We did host name, login ban, etc., all that sort of good stuff that we saw with the switch. Then we just configured an IP address on the router's interfaces, and we were able to have a host in VLAN 10 communicate with a host in VLAN 20. Like I always say, if you found this video useful, then please share it with others. If you have enjoyed this content, then please subscribe to my YouTube channel, and thank you very much for watching.